Acha, so our previous recording got corrupted, so I'm gonna just explain the Chebyshev wala the thing all over again. Uh, Firstly, let's look at exactly what the first question was saying. The first question is saying, okay, the probability show that if you have a flips, so you have a coin, and the probability of getting a heads on that coin is p, okay, and where you're doing n flips, the number of heads, let's say you get X number of heads, the probability of getting a head is P, right? We're trying to estimate what the value of P is. We're trying to guess what it is. So what we did was we just did n flips. Let's say n is equal to 100, और उसमें से फर्क कर लीजिए x is the number of heads, 30 heads आए, so आपने simply 30 upon 100 कर दिया यूज. अच्छा, मेरे ख्याल से p is 0.3. Now this is not going to be actual value, it's going to be an estimate, right? Now this value is थोड़ा, it's going to be close to the actual value, लेकिन थोड़ा ऊपर थोड़ा नीचे हो सकता है. So that's why it's called the p estimate, right? So p bar is basically x upon n, where x is the number of heads you got in the trials, n is the number of flips you did in the trials. ठीक है? What they're saying is show that the expected value of p bar is actually p, okay? Because p is a random variable that depends upon x upon n, where x is a random variable. And so this expression, ki jo value hai, it is basically also a discrete random variable, which is p bar, okay? Now, if I want to find out the expected value of p bar, I just want to find out the expected value of x upon n, right? This value, okay? And so the expected value of e of x upon n only really depends upon e of x upon n, because the expected value of n, तो ये तो नहीं बदलती, numerator ही बदलेगा. So if I want to find out this value, I just want to find out e of x upon n, right? So let's try to find out e of x. What is the expected number of heads? हम e of x निकालने की कोशिश कर रहे हैं. X को देखते हैं, x की value depend किस पे करती है? The number of heads basically depends upon the number of heads on the first flip, the number of heads on the second flip, the number of heads on the third flip, and so on and so forth, all the way until the nth flip. On each flip, it's either going to be a 0 or 1, the number of heads. Okay? We would like to find out the expectation of this entire variable, the total number of heads. And so the expectation of this guy is basically expectation of this entire sum. So expectation of x1 plus x1, x2, x2, x3, 4, all the way till xn, right? And so we can use a linear of expectation to make this. Acha, isko, we can just sum them individually on the expected values. So e of x1 plus e of x2, and so on and so forth, all the way up till e of xn. So we would like to find out the expected value for any xi. Okay? What is the expected number of heads on any ith flip? Okay? All the flips are independent, so this is all going to be the same. But what is the exact value? Well, for any xi, the number of heads on the ith flip is either going to be 1 or 0. The probability of it being a 1 is p, because p is the probability of getting a head, and the probability of getting a 0 is 1 minus p. It's really fairly straightforward. And so the expected value of xi is going to be 1 times p plus 0 times 1 minus p. And so we can just discard this value. So it's just going to be 1 times p. So the number of heads on any flip is going to be exactly p. Well, now that we know that the number of expected value of any flip is p, the number of heads on any flip is p, we can just sum up all of the expected values. तो हमने कहा था सबकी जो expected values है उसको sum करो. So e of x1 plus e of x2 plus e of x3, all the way from I is equal to 1 till n. And so all of them are p, sub p की value हैं. So this is going to be n multiplied by p. ठीक है, all their n values, their n flips, each of them has has p number of heads on it, unexpected. And so the expected value of x, the total number of heads, is simply going to be np. And so we wanted to find out e of x upon n, which is basically the expected probability of our variable p bar. And that's simply going to be np upon n. So yeah, उसको यहाँ पे लिख दिया. ठीक है? And so this comes out to be p. And so we got to know that expected value of p bar is actually exactly p. Okay. Now let's go to the second question. The second question says that assuming that the number of flips is alpha upon e square, where e is some threshold, बाद में देखेंगे. So we're saying we start off with the assumption that first कर लीजिए n is equal to alpha upon e square. If the probability, what is show that the probability of the distance of p bar from p bar from p का डिस्टेंस का क्या मतलब है कि फर्स्ट कर लीजिए, अच्छा, इफ द एक्चुअल वैल्यू ऑफ p was 0.3 और आपने टेस्ट किए तो 35 फ्लिप्स आए 100 में से, दैट मीन्स कि द प्रोबेबिलिटी यू केम आउट टू बी वाज 35. सो p bar जो एस्टिमेट था दैट केम आउट टू बी 335, बट द एक्चुअल वैल्यू ऑफ p was 0.3, or the expected value of p bar, or the actual value of p was 0.3. And so your error was actually 0.05. You're 0.05 off from the actual value. They're saying show that the error being greater than a certain threshold has to be smaller than 1 upon 4, given that n is equal to alpha upon the threshold square. Okay, show that this is true using Chebyshev's inequality. The first thing we're going to do is we're going to look at what the event that's being claimed is here. They said that the distance of p bar from p had to be greater than e, some threshold. We're just going to rewrite this event. Okay, it's the exact same event, so the probability should stay the same, but we're going to transform this event into something that's more closer to the Chebyshev inequality that we can use. And so we rewrote their event, which was the distance of p bar from p is greater than a certain threshold. We wrote that as uh, दोनों sides को multiply कर दिया n से, so it's still the same equation is still true कि if this value is greater than this value, the event is कि this has to be greater than this is the event. We're just going to multiply both sides of this equation by n, and so obviously this has to be greater than n. It's the same event. Just keep in mind that we're just transforming the event into something else, but it's exactly the same event. Like we're transforming the equation into something else, but it is still the same event. So as long as you've shown iski probability is smaller than 1 upon 4, you have essentially showed that iski probability is 1 upon 4 से कम. ठीक है? That's why we're transforming this. We're assuming that they're all the same events. ठीक है? So this event is now going to be, we can rewrite this as n times p bar minus p. यहाँ पे आ जाएगा en. And so this became n times p bar minus np is greater than ne. ठीक है? It's just rewritten. ये अंदर चला गया. ठीक है? Makes sense? Because modulus अंदर जा सकता है. अब हमने क्या किया? Let's look at what the value of np actually means. The number of heads being divided by the total number of flips gave us p bar, right? P bar is literally हमारा estimate, which basically हमारे जब ट्रायल किया गया फंक्शन हमने चलाया तो n flips किए तो उसमें से x is the number of heads we got, so we just divided x by n, and that's how we got p bar. ठीक है? So we can rewrite x as n multiplied by p bar. ठीक है? Also, NP, the number of flips multiplied by P, is the actual value of X, expected value of X. ठीक है? On average कितने आनी चाहिए था? If it was a perfect trial, तो हमारे पास exactly हमारी value आती N multiplied by P. ठीक है? So if the expected value of X is NP, हमने previously question में देखा था, we're going to call that mu, which is the average number of heads that you would get in the trials. So if we did 100 flips and the actual value of P was, let's say, 0.3, and you did this experiment a shit ton of times, so कभी 0.31 आया, 0.32 आया, 0.33 आया, कभी कम भी आ गया, लेकिन on average it would come out to be 0.3. So the expected value or the average value of the number of heads is actually mu, or basically NP, right? And so NP is basically expected value of X. We're going to rewrite that as mu for now. Okay? So we rewrote this guy यहाँ पे हमने देखा था as x, and we wrote this guy as mu. ठीक है? So now our equation has become the distance of x from the average value of the number of heads. So this is basically saying okay, how far is the number of heads from the average number of heads, or the actual number of heads you should have gotten if you had the exact perfect probability, right? And so now this equation is saying, what is the probability that this event happens? This should still come out to be less than 1 upon 4. It's the same event. It's just rewritten like this. ठीक है? हम क्या करेंगे अब इन दोनों sides को square कर देंगे. It's still the same event because it still holds true. X minus mu square किया, उसको भी square किया, तो ये आ गया modulus की जगह, because इस modulus को square कर लो. If that side was bigger than that side, then इसका square will be bigger than उसका square. सही है? ठीक है, so इसको स्क्वायर किया, उसको भी स्क्वायर कर दिया. Yeah, सही है. So now our event has become the distance of x minus mu, so the distance from the actual value squared, is greater than n square e square. Now we're not greater than n e, e जिससे हमने शुरू किया था threshold. Now we're greater than n square e square, but this value is also changed. So let's first look at Chebyshev's inequality. Chebyshev's inequality proposes the probability of any random variable का distance being the distance of any random variable from the mean value of that variable. So in this case, हमारा x क्या था was the number of heads, and the mean for our x was basically the average value for the number of heads you would have gotten, which came out to be exactly np. इसलिए हमने mu के तौर पे लिखा हुआ है. ठीक है? So Chebyshev says that the probability of the distance of a random variable from its mean being greater than k sigmas. So in English, you would say this as the error in the value of x, the error in the value of our random discrete variable, or the distance of your discrete random variable from the average value of that variable being greater than k standard deviations, is smaller than 1 upon k square. That's what Chebyshev's inequality is. We can rewrite Chebyshev's inequality as this. We just took the Chebyshev का event जो था उसको थोड़ा change कर दिया. Chebyshev का event क्या था कि your distance from the mean should be greater than k sigma. तो मैंने कहा कि अच्छा the distance squared should be greater than k square sigma square. Same thing, लेकिन हमने थोड़ा rewrite कर लिया है. ठीक है. I think this is another version of Chebyshev. I don't exactly know. So I'm just gonna say कि अच्छा we transformed the event in Chebyshev वाली inequality. तो अब हमारे पास आ गया कि चेबीशेव का इवेंट क्या कहता है. चेबीशेव का इवेंट कहता है बेसिकली कि द प्रोबेबिलिटी दैट योर एक्स माइनस म्यू, योर डिस्टेंस फ्रॉम द मीन स्क्वायर्ड, द स्क्वायर डिस्टेंस फ्रॉम द मीन, being greater than k square sigma square is smaller than 1 upon k square. The event is the same, so the probability stays the same. हमने बस इवेंट को रीराइट कर लिया है. अब हमारा इवेंट क्या हो रहा था. हमारा इवेंट हो रहा था कि x माइनस म्यू, सो द रैंडम वेरिएबल हमारे जो हेड्स थे, they being far, how far from the mean, uh, their distance from the mean has to be greater than their square distance from the mean has to be greater than n square e square. The Chebyshev वाला is कि you have to be greater than k square sigma square. अब हमारा तो है n square e square, इसके अंदर तो कहीं सिग्मा आ ही नहीं रहा. We would like to find out the probability of this event, right? Chebyshev says कि अच्छा if you are k square sigma square away from it, then the probability is 1 upon k square. So as long as you have k square, you know the probability of the event. But मेरे पास तो k square है ही नहीं, मैंने तो इस तरह लिखा हुआ है. So I'm going to rewrite this expression as k square sigma square. So first we're going to say अच्छा n square e square is basically going to be k square sigma square. We know what sigma in this case, sigma square in this case is. Sigma is basically the standard deviation, and sigma square is basically the variance. आप सबको स्टार्ट से पता होगा. And the variance of a binomial, क्या पता नहीं क्या कहते हैं, binomial distribution या जो भी binomial experiment या flip जो भी होता है, is basically npq, right? N times p times 1 minus p, इस तरह भी लिखते हैं. And p times q, it's a binomial event, sorry, binary event, कि या तो होता है या नहीं होता. So उस केस में the variance comes out to be n times pq. ठीक है. So we know that if we just divide this value by the variance, we're going to get k square. We're going to be left with k square. So we took our value and we divided by npq. Okay? So we divided n square e square by npq. We're going to be left with k square. Well, k square comes out to be n square e square upon npq. Simplifying that, we get k square is basically n e square upon p times 1 minus p. Okay? And so we know that the value of k square is this. Once we have the value of k square, we know that the probability of this event happening is actually smaller than 1 upon k square. और हमने k square अभी क्या निकाला है? ये निकाला है. So we know that the probability of this event happening is smaller than 1 upon this value. Okay? We're going to rewrite this exactly as that. We're going to say अच्छा, the probability that x minus mu square is greater than n square e square is smaller than 1 upon k square. 1 upon k square तो इसको basically ये k square था ना, 1 upon k square will be this guy flipped. तो इसको flip कर लिया. We said अच्छा, is this the probability of this event happening is basically this p1 minus p upon n e square. इसको बस reciprocal कर लिया because 1 upon k square लिखना था. ठीक है. And then we said अच्छा, this event की probability is smaller than this value, and we know that this value is smaller than this value. And why is that true? Well, look at this expression is basically p times 1 minus p upon n e square. तो अगर इसमें से 1 minus p हटा दो तो फिर इसकी वैल्यू बढ़ जाएगी. Makes sense because the value of 1 minus p is smaller than 1. 1 से कम ही है ना. It's like 0.7 या 0.8 या 0.3 या 0.4, anything. So this value reduces the value of this expression. अगर इस expression में से 0.2 या 0.4 का multiplication हटा दो तो इसकी value बढ़ जाएगी. So we know that the probability of this event is smaller than this guy, and this guy is smaller than this event. Sorry, this probability. ठीक है. So we said अच्छा, इसकी probability is also smaller than this p upon n square. ठीक है, इसको इस तरह rewrite कर लिया. एंड देन वी सर अच्छा, हमने कहा था कि n इज अल्फा अपॉन ई स्क्वायर, तो हम इसको डाल देते हैं हमारे n के अंदर. हमने इसको डाल दिया यहाँ पर. ठीक है. सो दिस बिकेम p अपॉन अल्फा अपॉन ई स्क्वायर टाइम्स ई स्क्वायर. दिस वाज n e स्क्वायर. दिस बिकेम अल्फा अपॉन ई स्क्वायर टाइम्स ई स्क्वायर, एंड दिस बेसिकली बिकम p अपॉन अल्फा, राइट? Now we know that the value that we started off with was, this was the event that we started off with, and we transformed it into this event. And so these are basically the same event. So if the probability of this event is less than this, then the probability of this event is also less than this, because it's the exact same event, we just rewritten it. And so the value of this guy, the probability of this guy is smaller than p upon alpha. Okay? Now, you know that the value of p is at max 1. And so if you want to show that this value is smaller than 1 upon 4, we just put alpha as 4. And at max, this value will be 1 upon 4. ठीक है, हमें दिखाना था कि इसकी वैल्यू 1 अपॉन 4 से कम होनी चाहिए, तो अल्फ़ा को बस 4 रख दो, इसकी वैल्यू लामहला 1 अपॉन 4 से तो कम होगी, हो सकता है 0.8 अपॉन 4 हो जाए या 0.3 अपॉन 4 हो जाए, कुछ भी हो जाए, लेकिन इन आइदर केस the probability of this event would also end up being less than 1 upon 4. So as long as you put alpha as 4, this equation holds true.